Hello friends, now in this video we're going to be discussing the addition of vectors. So we said that vectors are added geometrically, right? Geometrically, let's assume we have two vectors, vector A, which would be 5 Newton in the eastern direction, and we also have a vector B which would be 4 Newton also in the eastern direction. Now here we notice that 5 Newton is a longer vector and 4 Newton is a shorter vector. Now we said geometrically, which would mean now that these vectors have to be added, and when they are added we must take into cognizance the direction of these vectors. We must take into cognizance the direction of these vectors. Now, so since these vectors now are pointing in the same direction, we can add them up. So we're going to have our sum to be 5 Newton plus 4 Newton, while 5 Newton being a longer vector and 4 Newton being a shorter vector, which would give us 9 Newton. This would give us a resultant vector which is longer than both of our component vectors. Now let's assume these two vectors A now were to be pointing in different direction. 5 Newton going towards the west and 4 Newton B pointing in the eastern direction. How do we add these vectors up? So what we have in this case is that we're not going to be adding these vectors up. No, since they are pointing in different directions, our sum of these two vectors would be the difference. Yes, we're going to have to subtract these vectors because they are pointing in different directions. So we have that our sum now of these two vectors would be 5 Newton going towards the western direction minus 4 Newton going towards the east, and this now would give us our answer to be 1 Newton. And it's worthy of note to let you know that the direction of this vector would go towards the west. Why is it going towards the west? Because the 5 Newton is a larger vector. This is how we can do some simple additions of vectors. Now if we have two vectors inclined at an angle to one another, we won't be able to add them up using this method. Why so? Because of the angle between them. Now if we have a man who walks 3 kilometers due east and then walks 4 kilometers due south, to find his resultant vector now of movement or of displacement, what we need to do is to find the third side of the right angle triangle. In order to add up these vectors now, 3 and 4, we must find the resultant. So to do this, we use the Pythagoras theorem. Now this gives us r square would be equals to 4 square plus 3 square, 4 square plus 3 square. Now r square would give us 4 square gives us 16 and 3 square gives us 9. So r square would be 16 plus 9 gives us 25. So our arrow would be the root of 25. We take the square root on both sides, the root of 25, which will give us 5. And now we must find the direction with the horizontal. Because these vectors must have direction. So in doing this, we use tan theta because we have an opposite right here, which is our 4, and we have an adjacent side, which is our 3 kilometers. Now we use tan theta there. Tan theta will give us opposite over adjacent, right? So our opposite angle is 4 over our adjacent angle. Our opposite sides now is 4, and our adjacent side is 3. This gives us tan theta equals to 4 over 3 gives us 1.33. Now theta in itself will be equal to tan inverse of 1.33, and theta would then be equals to, tan inverse of 1.33 is 53.13 degrees. So that is what our direction